In the depths of the forest, where the trees reach for the sky, a hidden beauty lies, a world of endless wonder. In the patterns of the leaves, in the branches and the roots, a magic unfolds, a world of endless possibility. In the shapes of the snowflakes, in the swirls of the clouds, a dance of symmetry, a world of endless creativity. So let your mind explore and discover the secrets of this hidden world. A world of endless beauty. Hello there. Fractals are fascinating geometric shapes that are made up of smaller copies of themselves, arranged in a repeating pattern. These shapes often have intricate and beautiful designs, and they can be found in many different natural and man-made objects. For example, you might find fractals in a snowflake, a mountain, or a river. These shapes are not just pleasing to the eye, they also have many interesting properties and applications. For instance, fractals can be used to model complex systems and to generate computer graphics. The more you look at fractals, the more you will see they are like an endless maze of intricate patterns and shapes. So, the next time you see a fractal, take a moment to appreciate its beauty and complexity. You might be surprised by what you discover. What is the math behind fractals? Fractals can be generated using a variety of methods, including mathematical equations and computer algorithms. One common method for generating fractals is to use iterative algorithms, which are sets of instructions that are repeated over and over again. These algorithms typically start with a simple geometric shape, such as a line or a square, and then apply a set of rules or transformations to that shape in order to create a more complex fractal. For example, one common method is called the Mandelbrot set, which uses a complex mathematical equation to generate a fractal shape. Another method is called fractal flames, which uses a set of mathematical functions to generate intricate and beautiful fractal patterns. These algorithms can be quite complex, but they allow researchers to study and understand the properties of fractals in great detail. A Mandelbrot set is a complex mathematical equation that is used to generate fractal shapes. The equation is named after Benoit Mandelbrot, who is considered to be the father of fractal geometry. The equation is defined as the set of all complex numbers C for which the function f(z) equals z squared plus c does not diverge when iterated from z equals 0. In other words, it is the set of all complex numbers C for which the equation f(z) equals z2 plus c produces a finite value when z is set to 0, and the equation is repeated over and over again. This equation is used to generate the famous Mandelbrot set fractal, which is known for its intricate and beautiful patterns. The equation is quite complex, and it can be challenging to understand without a background in mathematics. However, it is an important tool for studying fractals and understanding their properties. Well, can we find fractals in real world? You can find fractals in many different places in the real world. In fact, fractals are all around us if we know where to look. For example, you might find fractals in the shapes of snowflakes, the patterns of leaves on a tree, or the branching of rivers and streams. You might also find fractals in the shapes of clouds, the arrangement of seeds in a sunflower, or the curves of a coastline. Fractals are everywhere if we know where to look. Snowflakes are made up of ice crystals, which form into complex and intricate patterns as they fall through the air. These patterns are often symmetrical and self-similar, which means that they are made up of smaller copies of themselves, arranged in a repeating pattern. This self-similarity is a defining characteristic of fractals, and it allows researchers to study snowflakes using mathematical techniques, such as geometry and calculus. Snowflakes often exhibit what is known as fractal dimension, which is a measure of how a shape changes as you zoom in or out. Snowflakes typically have a fractal dimension of around 1.3, which is in the range of most natural fractals. If we can find fractal patterns in our world, could the universe be a fractal system, a multiple universe? If the universe is a fractal, it could mean that the universe has an intricate and complex structure, with the same patterns repeating at different scales. This self-similarity is a defining characteristic of fractals, and it is what allows us to study them using mathematical techniques. If the universe is a fractal, then it would be like an endless maze of patterns and shapes, stretching out in all directions. This could have many interesting implications, and it could challenge our traditional ideas about the nature of the universe. For instance, it could mean that the universe is infinite in size, with the same patterns repeating over and over again on an enormous scale. Alternatively, it could mean that the universe is made up of multiple universes, each with their own unique properties and characteristics. The universe, a vast and wondrous expanse. A never-ending maze of stars and galaxies, a symphony of light and motion, a tapestry of beauty and mystery. And yet, beneath the surface, a deeper pattern lies, a fractal structure. The world within a world. For in the swirling of the galaxies, in the branching of the nebulae, in the swirling of the planets, we see the same shapes. The same patterns, repeating again and again. A universe within a universe, a world of endless wonder, a fractal symphony, a song of endless beauty. So let your mind explore and discover the secrets of this hidden world.